inequality. Are there any questions about the proof, by the way, before I erase it? Everything okay? Cool. Okay, let's remember. Let's start here. So the theorem again said that if P equals C over N, then probability that there exists a triangle in G and P converges to 1 minus e to the minus c cubed over 6 as it goes to infinity. We now want to prove the lower bound, right? So the proof is very simple. We just use the same events and apply the answer inequalities. So let A1 up to AM be the triangles in Kn. So what I mean is the triples of edges which form triangles. So these are subsets of n where n equals little n choose 2. Okay? So we think of this set as being just a collection of edges listed in some order. It doesn't matter what order. And each AI is a triple. Form a triangle. Okay? And then the Bj, so the Bj is the event that Aj is contained in GMP. Okay? So we pick a random graph GMP, which is the same as picking a p random subset of 1 up to capital N. And Bj is just the event that this triangle occurs in GMP. Okay. So what is mu? Mu is the sum from j equals 1 to m probability of Bj. Well, what is m? M is the number of triangles, so n choose 3. And what is probability of Bj? Well, it's the probability that Aj is a subset of GMP, 3 edges, p cubed. This equals n choose 3 times p cubed. And what is delta? Well, it's the sum over I tilde j, probability bi and bj. So which triangles intersect? Well, 2 triangles intersect if they're the same thing, but that's not counted here. So if they're different, the only way they intersect is if they share an edge. Right? Because remember that the set is a set of edges. Okay. So this is AI, and this is AJ. So I just want to sum over these things. Well, what's the probability of BI intersect BJ in this case? Well, it's 1, 2, 3, 4, 5, p to the 5. And how many different possibilities do we have? Well, we choose 1, 2, 3, 4 vertices, And then actually we get to choose this non-edge as well. Right? So that's 6 times n choose 4. And I'm going to observe that this is much, much smaller than mu. Right. It's much smaller than mu because it's basically n to the 4 times p to the 5, which is basically p times a constant. Right. This is if p equals c over n. So this is basically a constant. It's like c cubed over 6. And this is about p times a constant. Okay, so we apply by Janssen part A. Probability that there's no triangle which is the probability that there's no triangle in GMP. It's at most e to the minus p cubed n choose 3 plus this thing 3 n choose 4 p to the 5. This converges to e to the minus c cubed over 6. Then goes to infinity. Okay? Easy. So there's only a few minutes left, so probably I won't do any exercises, but maybe I'll try and send you a list of exercises from the first half of the course, which will most be... How many people have the book, by the way? Almost everybody. Okay, cool. So basically all the exercises I would send you are from here anyway. So if you're doing all these exercises, you should be in a good position. Probably I'll send you, for the evaluation of the course, a set of exercises to submit solutions to, and there'll be different ones, I guess. Or maybe I'll just give you a subset of these. That's probably the easiest thing. So if you're doing all the exercises here, you already have done them. So I'll send you those by the weekend, and maybe if you send solutions before Carnival. What else would I like to say? Yeah, so maybe the second half of the course will on Friday start with some applications from topology, so we have a quick vote. Has the course been going so far too slowly or too fast or just right? So I know how fast to judge the second half. Let's have a vote. So, I'm going to start from this side so people don't get too embarrassed. So who thinks that everything has been exactly the right speed? Should neither slow down nor speed up? 1, 2, 3, 4, 5, 6, 7. That's quite a lot. Okay, so that's looking good. Okay, so I don't think we even need to vote. Okay, so maybe the rest are you fasts or slows? How many too fast? And how many too slow? Okay. So that means that I'm allowed to speed up very slightly, and all the people who think it's just right have to complain if it speeds up too much. So I think naturally it will speed up, well, in the sense that things will get a bit harder, so if I keep going the same speed, it will seem like it's faster. Okay, that's great. Right, so I'll hopefully send you some exercises, and I'll see you all on Friday.